In this video, I'm going to describe how you can start solving equations that have an absolute value. And then in the second half, we're going to take this idea a little bit further by mixing those absolute values with the inequalities you already know about, and seeing what changes this will bring about to the solving process. So if you look in the book on absolute values, it probably says something a lot like this. For any number a which is greater than 0, and an algebraic expression x, when you have the absolute value of that expression equal to a, then this becomes basically two statements, that the expression is equal to a negative a, and that the expression is equal to a. Now, let's go ahead and examine that just a little bit more with, say, something a little bit more concrete, and see exactly what that means. To see why you basically get two possibilities, imagine what happens if you have a problem like the absolute value of x is equal to 2. Think about what possible things x could be. Well, since the absolute value basically removes any information about the sign, we know that x could be a positive 2 or a negative 2. In using the language of the expression, this is kind of what you do. You take the part inside absolute value, and you think, well, maybe it could be negative, or maybe the part inside could be positive. So I've split it up into a negative x equals 2 and an x equals 2. And what I'm going to do with that one on the left is basically multiply both sides by a negative 1. And that will give me that x is equal to a negative 2. So in this way, I basically get two solutions. So in summary, here's basically how we're going to solve an equation that has one of those absolute values in it. First, we're going to isolate the absolute value to one side of the equation. Once it's isolated, we'll go ahead and split it into two problems. One of these problems will take care of the negative case, in other words, what happens if there's a negative number inside the absolute value, and the other case will handle what happens if what is inside absolute value is actually positive. And we'll solve each of those cases separately. So let's start off with a nice example to see this in action. Here I have the absolute value of x minus 3 minus 1 is equal to 4. So what I'm going to do is first try and isolate the absolute value. And I'm going to do this by adding 1 to both sides. That'll make sure that the absolute value is the only thing on one side of the equation. Now once I have this, now I actually split it into two different problems. I'm going to split it into a negative quantity x minus 3 equals 5 and x minus 3 equals 5. So notice how that part inside absolute value, basically on my first problem, I'm going to give it a negative sign, and on the second one, I'm not. Now I'm going to solve each of these two separately and see what my solution is. On the one on the left, my first step is to basically move that negative sign to the other side. So imagine multiplying both sides by a negative 1. This will give me x minus 3 is equal to a negative 5. Last, go ahead and add 3 to both sides, so we get x equals negative 2. So that will be one of our solutions. Now let's go ahead and take a look at the second problem. For this one, there's not a whole lot of work. All you have to do is add 3 to both sides, and that will give you x equals 8. So in this way, we can find both the solutions, that x is equal to negative 2 and that x is equal to 8. Now remember, if you're ever unsure about your solutions, you can take them and test them in the original just to see if they balance out. Alright, let's try this with another example. Here I have 1/2 times the absolute value of 5x plus 2. And all of that is equal to 6. So again, my first thing that I'm going to do is try and isolate that absolute value by multiplying both sides by 2. This will make sure that the absolute value is the only thing on the left. Now that the absolute value is isolated, split it into two different problems. One that takes care of the negative sign, and one that's basically exactly the same without any absolute values. And solve each of these separately. With one on the left, go ahead and move that negative sign to the other side as your first step. Then imagine subtracting 2 and dividing by 5. So this will give us a solution that x is equal to a negative 14 divided by 5. Then turn your attention to your second problem and solve that one. So this one, we need to subtract 2 and then divide by 5. So here we have our two solutions, that x is equal to 2, or that x is equal to a negative 14 over 5. All right, just one more example, but be very careful with this one. Here we're going to take a look at the absolute value of x plus 2 is equal to negative 3. Now, be careful about going through the process in this one, because remember, when you take the absolute value of a number, it always returns something positive. For example, if you take the absolute value of 2, you get a positive 2. If you take the absolute value of a negative 2, you still get a positive 2. Now, what that means is that no matter what we try and use for x, as soon as it takes the absolute value, there is no way it's going to get a negative 3. So this particular equation actually has no solution whatsoever. Now that we can solve an equation that has an absolute value, let's start working in those inequalities to see what other changes will happen. When you solve an equation that has an inequality, remember that you basically want to flip the sign if you ever multiply or divide by a negative number. That's going to play a huge part as we split it into two different problems. So here's basically what we have. If you have some sort of expression and you have a number greater than 0, then depending on which way that sign is going, it will split it into two problems like we saw before. Furthermore, those two problems that you split it in will either be connected using the word and, or it could be connected using the word or. Now recall when we were solving those compound inequalities that this could have an effect on what our solution looks like in the very end. So now what we're going to do is take a look at some simple examples to see how all of this works in. Here are some quick tips before we get started on that process. First, think of splitting your problem into two pieces like we did before, one taking care of the negative case and one taking care of the positive case. Also, watch the direction of your inequality sign. That really determines how you need to connect them. If you have the absolute value less than some number, then you want to connect those two problems using the word and. If you have the absolute value greater than some number, then you want to go ahead and connect them using or. And of course, be very careful with your technique, whether you're using and or, and what you should be doing. In this first example, I've picked something nice and small. The absolute value of x is less than 3. And watch how I proceed through this. So the first thing I want to do, since the absolute value is basically already by itself, is to split it into two problems. One will take care of our negative possibility and one will take care of our positive possibility. So negative x is less than 3 or x is less than 3. Now, because I have an absolute value less than a number, I'm going to connect these two guys using the word and. And that may not seem like it's going to make a huge difference, but watch how it has an effect on our solution. So, like before, I'll take each of these and solve them separately. With the one on the left, there's not a whole lot I need to do other than isolate the x by getting it all alone. So imagine multiplying that one on both sides by a negative 1. Now remember, we're dealing with inequalities here. So when I multiply by that negative 1, I have to flip the sign. This will give me that x is greater than a negative 3 and x is less than 3. So what I'm going to include in my solution are basically all numbers that are greater than negative 3 and they must be less than 3. It must satisfy both of those conditions. Therefore, our interval goes from negative 3 up to 3 and includes everything in between, and that's it. Let's try another simple example so this gets better in your mind. Here I have the absolute value of z is greater than or equal to 5. Okay, so first, imagine splitting this into two problems. Negative z is greater than or equal to 5, or z is greater than or equal to 5. And notice how, since I have an absolute value greater than or equal to, that I'm using the word or to connect these two. Again, this will have an effect on our solution. Now I'm going to solve each of these separately. With the one on the left, imagine multiplying both sides by a negative 1, and that will flip my sign. So I'm looking for numbers such that they are less than or equal to a negative 5, or I'm looking for numbers that are greater than or equal to a 5. So I'm looking for numbers that either satisfy one condition or they have to satisfy the other condition. So in this case, I actually get two different intervals. all the numbers between negative infinity up to negative 5 inclusive, or all the numbers from 5 up to infinity. All right, now we're ready for one that has just a little bit more work associated with it. Here I have the absolute value of 3x plus 2 is less than 5. Well, the absolute value is already isolated, so let's go ahead and split it into two different problems. Because I'm dealing with the absolute value as less than a number, I'm going to use the word and. In one case, I'm dealing with the negative possibility, and the other one, it's exactly the same, just no absolute values. So let's solve each of these separately. With the one on the left, my first step is usually to move that negative sign to the other side. And when I multiply both sides by, say, negative 1, it will flip that sign. Now I'll go through and try and isolate the x. So subtract 2 and divide by 3. So this will tell me I'm looking for values of x that are greater than negative 7/3. Then turn your attention to the other one and solve that. So subtract 2 and divide by 3 to isolate the x. And that will give us that x is less than 1. So what you will include as your solution for this one are all the numbers that satisfy both these conditions. So it must be greater than a negative 7/3, and it must be less than 1. So this gives us the interval of everything between negative 7/3 up to 1. For this next example, it looks pretty similar, but notice how I've switched the inequality symbol. So now I have the absolute value of 5 minus 2x is greater than or equal to 1. So when this gets split into its two problems, I connect them using the word or. So let's take care of the guy on the left by moving the negative sign to the other side and making sure we flip the inequality symbol. With this one, I need to subtract 5 and then divide by negative 2. This will give me that x is greater than or equal to 3. Looking at the piece on the right, 5 minus 2x is greater than or equal to 1, I'll do pretty much the same steps. Subtract 5 and then divide by a negative 2. Now notice in that one, I divided by a negative 2, so I had to flip the sign. So in this case, I'm looking for numbers that satisfy either one condition or the other condition. So x must be greater than or equal to 3, or x could be less than or equal to 2. So this one has two intervals. Now since it has or equals to, make sure you're putting those brackets on to say that it is okay to include the 2 and it is okay to include the 3. Just one more example before we finish. Here I have the absolute value of 3 minus 12x is less than or equal to negative 3. Okay, now think about this one for a bit and notice that it actually has a bit of a problem. Remember, when you take the absolute value of something, it's always positive. And what this says right here is that you're looking for the absolute value and when it is less than a negative number. And there's no way that can happen. And since there is no way that can happen, it means that there's no possible x we can plug in there that would make this statement true. So watch out for cases like that, where there's no work involved. You basically just have to realize that the absolute value only produces positive values.